All right, today we're going to be going over some information I've been putting together for a project, halogen ellipses. We've been experiencing some interesting interference through deep space with regards to Voyager 1 and Voyager 2 with intermittent issues with communications due to compressions on the Higgs field and electromagnetic interference. We've also been expanding on the understanding of the Higgs field itself. Instead of being a Higgs particle, we have a Higgs field, which is a very interesting subject matter to discuss. The Higgs field, as it's understood right now, would be a lattice network of coinciding energies that compress and expand upon each other based upon the interaction of waveforms. These waveforms, or wave functions that come through the Higgs field, are actually what generate what we would consider a particle interaction. So the Higgs field itself would be considered a network of energetic intersection points that are representative of the amount of energy that is expressed on the Higgs field in all directions. We can look at that as a form of directional energy, and we should be able to pick up on a new type of communication if we explore the possibility of the Higgs field actually being quantumly locked or not with different types of wave function interactions. We can take into account that there may be a form of communication where we lock a quantum wave function into place with a wave function at a different point. Now we say a quantum particle and a quantum particle, but to look at it properly, we would say this wave function is creating a particle in the Higgs field. And we can actually utilize that to compress the Higgs field and affect a particle into existence, or affect a particle that already exists in our observer effect. If we're able to do that, we can postulate that there may be a more advanced civilization or a civilization, some existence out there that would be able to do the same thing. If they can send a wave function in our direction utilizing the Higgs field, causing a compression and a collapse in a specific point. So they would create a wave function in their vicinity of the Higgs field. That would cause a uniform directional collapse or a uniform directional compression of the Higgs field, and you could actually target an area of the Higgs field you are wishing to communicate with. If we take that compression and collapse of the Higgs field at the endpoint, then we can understand that a type of communication can occur between the beginning point and the end point. It's a very simple concept with a very complicated set of mathematics that go into it. But simply put, we're able to detect these types of collapses in the Higgs field that are either uniform, mathematically significant, harmonically significant, graphically significant. Then we would be able to determine that these collapses are not natural. They're created. If we can determine the direction of these collapses by finding a quiet part of space where the Higgs field is not commonly interacted with by gravitational forces, solar winds, then we would find a space that would be able to utilize in order to deploy a set of sensors for quantum field analysis. We could look for differentials between mass changes, energetic dispersion changes, energetic directional changes, and determine the general direction of an attempted communication. Given that understanding, with analysis of the different parts of our solar system that are actually quiet in regards to gravitational forces, solar winds, atmospheric sources or atmospheric pressures, and other coinciding forces that would go along with those, we can determine there would be two viable options right now. There's the Lagrange point 2 between the sun and the earth, and there is the Lagrange point 2 on the opposite side of the moon. Now, the location between the sun and the earth would only be shielded from different types of solar or mass ejection issues that could affect the Higgs field greatly during very specific points in time, like when we have a solar eclipse from either the moon or from Venus or in our other interfering bodies. And those would be very pinpoint types of shielding from that type of effect. The other area that we could look at would be the Lagrange point 2 on the opposite side of the moon, because it is shielded from not only the Earth's gravitational field, it can be shielded from the sun's gravitational field, along with the sun's mass ejections that it creates. Any particle ejections, like energetic ejections, can be shielded from that as well. We utilize that. That gives us a much broader window that we could utilize in order to run sensors and detection modules that would allow us to pick up on those minute changes. If we can do that, we expand our window of availability to monitor and also to detect if there are any communications coming in on a quantum level. These types of communications could be utilized if, say, a spacefaring race or civilization were to send out a communications array that had these capabilities, and they just sent it and waited for any type of interaction to come back, which would be a dark forest scenario, essentially. There could also be the situation where a civilization was meeting an apocalyptic scenario, or maybe they just wanted to explore the cosmos and figured out certain types of longevity in life that we currently do not know, and set out to the stars. And they can utilize these types of communications as well, but they can only interact with and determine locations and survivability of interactions by finding civilizations that would actually have these types of technologies that still exist. So if we understand these types of interactions, then we need to also understand that if we create a communications board or a module to communicate back, it's going to have to be a quantum interference module. That means that the technology we currently use is on the baby steps. On a national level, each nation that is currently developing these structures and these systems are on the cutting edge of what the human race is developing. As a world, and if we look at it in a cosmological sense, even though we are quite far out on the disk for our observable universe, there are still areas much, much farther out from us, and there are other universes that would be able to communicate back and forth if this technology exists. The other implication we need to look at is that it has not been very well studied or understood or talked about, is if that a particle function and a wave function are intrinsically tied to each other, or if there is an observer requirement for a particle function to actually come into existence. If a wave function has to be observed, if the effects of it have to be observable by, say, a conscious being or a sentient being, for it to be interactable as a particle, then we could postulate that if a wave function is not observable by a sentient being, then it stays a wave function. So that leads into the question, do wave functions have a time limit? Do particle functions have a time limit? If a object is sent into space, into deep space, into another galaxy, into another universe, and it goes unobserved by a sentient being directly, does the particle function collapse, causing it to interact only as a wave function? And then what implications does this have? If a wave function, like a beam of light, so a proton is too small for a human being or a sentient being to observe directly without some type of mechanical intermediary. If a proton can travel from one end of the galaxy to the other end of the galaxy, and it only observes decay in the range of frequency, or the space in which the frequency is spread out. So as it travels, it slows down. So we have a blue light that becomes a red light, or blue emitted radiation becomes red emitted radiation. So we understand that. But if there is a object, let's say a baseball, and you throw that into space, and you know that that baseball is going to continue moving indefinitely, and we lose conscious observance of it, does that baseball stay a physical object? Or would the matter that it consists of reduce down to a wave function, no longer existing as a physical object? Now, the limitation of that would be, do we have to physically be able to observe it in its wave functions for those to collapse into particle functions? Or would we physically have to be able to interact with it? And then what time span does it take for an object to go from a particle function to explicitly a wave function before it can collapse back to a particle function under observance again. This embodies the concept of Schrodinger's cat, along with the double slit experiment, along with the mirrored universe issue, and several other studies that have gone on in regards to why particles will act as a wave function and as a particle function at the same time, but only under certain observational settings. So that is my posit. So the understanding for my business is going to be that Integrity Technology Innovations WR is going to be developing a system known as Heliogen. We're going to be petitioning, I'm going to be looking for employees in order to help develop an interface for this to begin with, a UI. We are going to be looking at developing a interactive system in communication standards only for when this becomes a reality, when we can utilize this as a communication standard and a determining standard for directional intelligence gathering. If there are spacefaring people out there, spacefaring civilizations, and they want to be heard, this would be the most probable way for it to happen. Not by radio waves, not by light beams, because light beams change. They change different types of frequencies as they travel through space. But when we start to understand the Higgs field and quantum interference, quantum mechanics, and quantum field theory itself, we understand that this is a reality we are coming to. So if you're interested, I will have a application form up very soon. We will be looking for interested engineers, developers, astronomers, astrologers, anybody in the field of quantum mechanics, quantum field theory. If you have an interest, if you would like to get in on the ground floor, I don't care if you want to make a logo design at this point, but that's what we're going to be working on. So I look forward to seeing you there.